Hello guys, welcome to the Havel Lab today. My name is Babatunde Arowolo, and today we're going to be talking about basic properties of logarithm. Okay, so on this table here, we're given I basically just wrote down some logarithm functions. These are the logarithm functions, basically the properties of the logarithm functions, especially when we're dealing with multiplication, division, or exponent. Okay. So when we're dealing with multiplication, whenever we're dealing with multiplication in a logarithm function, you should always add those logarithms. Okay. So whenever you're given a logarithm function in multiplication, let's say we're given log 2 a times b. This means we're gonna have to find log 2 base a and add it to log 2 base b. Okay, so it's kind of the same concept in the next two ones. So look at this is log 2 for the second property, which is the division property. Log 2 bracket a divided by b. This will be equal to log 2a minus log 2b. Okay, so basically we're just kind of subtracting from both sides now. All right, so the third one is an exponent. Exponents basically means powers. So if you say 5 to the power 3, right, this is an exponent. Okay, so this is the exponent property of the logarithm function. Okay, so this basically means we have to take that exponent, which is the power here, and multiply it by the logarithm of whatever we're looking for. Okay, so in this case, let's say we're looking for log 2a raised to the power b. We have to say b times log 2a. Okay, so let's apply that in this question. This is the first question is log 2 5 plus log 2 9 equals log 2 what? Okay, so if we take a look at these at these properties that I wrote, this I really strongly advise you to really understand or write down, or wherever you can jot this down, just trying to just so you can see it. Or yeah, it would be good if you really know it off head also. But yeah, so we should always have this in handy. Okay, so you can work with logarithm problems. Okay, so this is log 2a. What this means is just saying log 2a plus log 2b, right? This is the same question we're giving here. It's basically the same thing. It doesn't, and another thing, it doesn't matter about the logarithm. I just use log 2 as an example, right? You can use log 10 or log 4 or something. It doesn't matter. Okay, so this is log 2 5 plus log 2 9, right? And since they're adding them together, the result is supposed to be a multiplication of these digits, this a and b digits in this case, right? In this case, a and b are 5 and 9. Okay, so for us to get the answer, we have to multiply 5 and 9, and that equals log 2 5 times 9, right? So that would be equals to log 2 is 45. Okay, because 5 times 9 equals 45. Okay, so that's done. Let's get the next question. Next question has to do with a minus. Okay, so when we're minusing, we have to divide the a's and the b's. Okay, so we are aware of that. So let's look at this. This is b, this is log 4. Okay, so I want to put an x over the box that I'm kind of finding, because it's yeah, because we're looking for it, so we have to put a variable. So this is log 4x minus log 4 7 equals log 4 5 divided by 7. Okay, so if you take a look at at the second property has to do with a minus. And so when we're dealing with minus, we know that after we've identified the a and the b, we can then divide that in this in this side of the equation, right? So this side of the equation is, in this case, this one. Okay, this is this part of the equation, because we're actually dividing in this case, but this part has to do with a subtraction. Okay, that's the same thing here. We're subtracting and then we're dividing here. Okay, so we know which part we're working with. And so when I'm doing with these type of questions, what I want to do is I want to check if the logarithm functions are all the same, right? If all these numbers here at the bottom are all the same. Okay, so since they're the same, we can kind of make this equation, we can kind of combine this equation into a bigger, so like we can just combine into one entity basically, right? So we can say log 4 into x divided by 7, or we can say x over 7 equals 5 over 7. Okay, because we know x, anything with minus is equals to division. Okay, when we're subtracting in this form, we're always dividing. We want to divide. Okay, and so we know when we divide x and 7, that gives us x over 7, and the answer we get is 5 over 7. Okay, so when we do that, but when we divide this should give us a 5 over 7. Okay, and a simple approach to doing this is, since the denominators here are both the same, that means whatever's here should also be the same thing as whatever's here. Okay, so basically this just means log 4 x should be equals to 5, right? So the reason x is equals to 5 is because the denominators are the same, right? And it kind of makes common sense, because since this is basically saying x divided by 7 equals to 5 divided by 7. Okay, so for this part of the equation to be equals to this part of the equation, we have to make x equals 5, and x is what we're looking for. Okay, so this is log 4 base 5. Okay, so let me put that down. This is 5. Okay, so let me look at the next question. The next question is saying log 7 raised to the power 1 over 4 equals empty box log 7 2. Okay, let me write that down. Okay, so we have to observe this question. At first, we know that the log 7 are actually the same on both sides of the equation, right? So we're chilling, we're good for now. Okay, so this is log 7 to the power 1 over 4 equals x log 7 to 2. Okay, so if you look at this question and this question, they're kind of similar, right? They're a bit similar, right? And in order for us to find the b in this place, right? Because as you notice, there's an exponent of b here, but in this place there's no exponent of b. We just have 1 over 4. And so in order for us to find the exponent of b, we have to ask ourselves, what do we think that can relate 1 over 4 with 2 here? Okay, so basically this is saying, what do you think that when we put in the exponent of as 1 over 4 is going to give us a 2, right? So we'll put this one as x here. I will come here and we'll say log 7 into 1 over 4 to the power x equals to 2. Okay, so we're going to ask yourself, what do you think that when I when I when I multiply, when I kind of divide, when I kind of find the exponent of this number, what do you think will give me 2, basically, right? So 1 over 4 is the same thing as log 7 to the power 2 minus 2, right? We all know that, because raised to the power minus 2 is the same thing as saying, okay, so let me give an example. This 3 minus 2, since we have an exponent of minus at the top, this is going to say 1 over 3 squared, because we want to remove the minus. Okay, and since this is the kind of reciprocal of 3 squared. Okay, so since we got the reciprocal here, because if you look at this, it's kind of in the same format. If you got the reciprocal here, it's kind of telling us the same thing, honestly, if you look at it, in this same format. Okay, so we're going to find the negative exponential power to this. When we find the negative exponent, that is a 1 over whatever we're working with, right? Basically the reciprocal. Okay, and the reciprocal of 1 over 4 to the power x is in this case, because we want to find an exponent that relates with 2, right? So since it relates with 2, this is 2 raised to the power minus 2 equals x log 7 is 2 now. Okay, so now we're on the right track. Okay, this looks like this now. Okay, so now we're good, right? And so since we know b here is -2, so this is b, because b here is -2, we can easily just plug in b as -2 here. Okay, so in this case, instead of saying b, we're looking for x, right? So since we are aware that this is x, right, and x equals -2, so you can just come here and say x equals -2. Then plug that in. This equals -2. Yeah, okay. So thank you very much for watching the video. I really hope it helped out, and have a beautiful day ahead.